In section 3.5, we want to discuss something called a conditional probability. So this is a probability of one event given the condition that another event has occurred. And the given is indicated by a vertical bar. So that vertical bar means given. So that's the probability of A given that B has already occurred. So that's our keyword there, given. And what the given probability does is it restricts your sample space. So we define the probability, conditional probability of A given B to be the probability of A and B occurring divided by the probability of B. Now, if our sample space is equally likely, then we can just use the raw numbers here. So the number in number of sample points in A intersect B divided by the number in B. So let's look at an example here. So we've got three sets A, B, and C, and 1, 2, 3, 4, 5, 6 are our sample points. Here's the probability of those sample points. So first, the probability of A. So that's going to be the sum of the probabilities of the sample points. 1, 2, and 3. So this is going to be 0.2 plus 0.05 and plus 0.25. So I just added up the probability of the three sample points there. So that's 0.5. And then probability of A intersect B, A and B, the overlap, only 3 is in the overlap. So this is equal to the probability of 3, which is 0.25, right here. Probability of B given A. So by definition, this is going to be the probability of the intersection B and A divided by the probability of the given event, probability of A. So B and A is the same as A and B, that's 0.25. And then probability of A is 0.5 right here. So 0.25 divided by 0.5 is 1/2 or 0.5. So that conditional probability is 0.5. Probability of C given A will be probability of C and A divided by the probability of the given event, A. So we know the denominator, probability of A, is just like it was above, 0.5. And then C and A, so let's see here, C and A have no overlap. They are disjoint, mutually exclusive. So that probability is 0. So 0 out of 0.5 is 0. And then probability of C given not A, so that's going to be probability of both events, C and not A. So C and A complement divided by the probability of the given event, A complement. So C and not A, so you're in C, but you're outside of A. Oh, well, that's all of C. So this is just going to be the same as the probability of C, because all of C is outside of A. And then the probability of A complement is 1 minus the probability of A. That's complement rule. So your probability of C, there's two sample points in there, 5 and 6, so we add their probabilities. So this will be in the numerator, 0.15 plus 0.25. And then in the denominator, probability of A, we figured here was 0.5, so 1 minus 0.5. So let's see, that's going to be 0.4 divided by 0.5. So that's 4/5 or 8/10, 0.8. So that's conditional probability, and we had to use the probability formulas. We couldn't use this one because we did not have an equally likely sample space. So just remember here that your given event, that's the probability that goes in the denominator.